Yeah, that's all except the only part of electroscope I didn't. Anyways, let's just quickly finish electroscope. It will take hardly 5 minutes. Okay, so let's understand. That's a very easy topic. Give me a minute. Okay, so let's understand the electroscope as an instrument. Very easy. Electroscope. So an electroscope is an instrument which helps you to detect whether a body is charged or not. It can only tell you whether the body is charged or not. But this switch on your camera, this body is charged or not, but it cannot tell you whether the body has a positive charge or a negative charge. That it cannot tell you. It can only say whether the body is charged or not. Okay, so what is the construction of an electroscope? Very simple. You can make it at home also if you want. So we usually use some sort of a jar. So let's say this is a jar, okay, a closed jar, this sort of, and on this jar you will actually have a cardboard which will seal this electroscope. There will be a cardboard which will seal it, right? And then you can take any of those gem clips or metallic clips which you have, and you can insert the metallic clip inside it. Say there is a metallic clip which is inserted, and say the clip is kept. So simple paper clip can be turned, right? And when you eat that new Kit Kat or the dairy milk, then you can snip off two small ribbon sort of thing of that foil, okay? And let's say that foil will be in this manner. In a V shape, the foil will be stuck here, V shape. Now, simple idea. The foil is conducting material, the clip is conducting material. So what happens? Say suppose I bring a charged body near this particular electroscope. What can electroscope do? An electroscope can only tell you whether the body is charged or not. It cannot tell you whether the body is positively or negatively, right? So what it does, say for example, I have brought a positively charged, what you call a body, and your body is made to come in contact with this clip. As soon as it comes in contact with the clip, don't you think the charges will flow through the clip? And then what will happen? They will flow to both the strands of this little foil. Both get charged. Now just apply your brains. This one will be positively charged. Even this one will be positively charged. Like charges repel. So our strands, which were originally say in this manner, the strands will now become far apart. That's the only test that you get to know that this is what? This is a charged body. Okay. Now that's interesting. Suppose, and now you remove this particular, what you call rod from here, bring another body which is also say charged. Now I'm not telling you what sort of charge it is having. Bring another body which also has charge. After keeping that body in contact, if you still see that they are still far apart, that means the body which is you brought next time has the same charge as the body of previous time. That's why na same charges have flown. Earlier maybe five charges gone. Now some another 2 extras have gone. But the nature of charge is same. But if you bring a body which is oppositely charged to the previous body, then what will happen? These charges will flow to that body, or they will neutralize. End of the day, charges won't be there. So our separated fangs will then come close to each other. Close to each other tells you that the next body which you brought, that is a body which has charge of opposite polarity to the first. But you still can't say whether it was positive or negative unless you know the first body was positive or negative. Say instead of this, if I would have brought another body, let's say I would have brought a negative body. Now forget about this body, okay? Let's forget this body. Say this body was not in contact and I brought a negative body in contact. You brought a negative body in contact. The negative charges will flow. Again, the fangs will separate. So what is electroscope? Electroscope is a device which helps us understand whether a body is charged or not. What does it comprise of? It comprises of a jar and a metallic pin to which very light foil, aluminum foils are attached. That means you have brought a charge, not positive, you have brought a charged body. Even if negative, it will go apart. Even in negative, it will go apart. See, why does it go apart? It will go apart only when there are similar charges on both. So if you give a negative body in contact, the negative charge travels to both, it goes apart. Very simple. If you bring a positive, once it is charged, after that, if you bring another charged body, you may either see more diversion or contraction. If you see contraction, that means the next body that you brought has a charge opposite to the previous one. And if you see more bifurcation, that means you brought another similar charged body to it. That's only about electroscope. Clear? Any doubt with anyone? So what does it comprise of? It comprises of a jar. It has a metallic pin to which two light strands of aluminum foil are attached. On bringing a charged body in contact with this film, what will happen? The films get charged. As a result, they repel, whatever it may be, positive or negative. An electroscope cannot tell you the nature of the charge unless and until you know the nature of the charge on the body. It can only tell me whether the body that I brought is charged or not. It is positive or negative, we cannot get to know. Unless we know that this is now, abhi maine negative charge laya. So once I bring it in contact, what will happen? Both will bifurcate. Next, I bring a positive charge, they will neutralize, so both will come close. Coming close on the next time means that it got discharged. No, it got discharged. Original charges have been neutralized. That means the body that you brought next time was actually opposite in nature to the body first. That's all. Okay, that concludes lighting. So let's go to our next topic, which is that of earthquake. Let's talk a little bit on earthquake. What is earthquake? A sudden shaking of the earth is called earthquake. If the shaking is too violent, the calamity will be more. Yes or no? The damage will be more. Usually, earthquake. So let's see. Say storm. Then you have floods. Then you can have cyclone. And then you can have earthquake. And we studied about something called lightning. Yes or no? These are all natural phenomena which causes calamity. Tabahi lata hai ye sab, calamity. The interesting thing is this one can be predicted. This fellow cannot be predicted. There is no such science till date that you can say an earthquake is going to happen. In Hyderabad, last few months back, we used to have so much of rain. Your schools used to get closed. You used to get warnings that there will be a lot of rain today, schools to remain closed. So these all, now science has come so much, meteorological sciences are so advanced that you can predict all this. And if you can predict this, can you stop it? No, you can't stop it. What you can do is that you can take corrective measures in advance. Like, you know, there will be storm, so you can deploy NDRF team, you can deploy rescue team in advance. You can have people stand by. इसका हम कुछ नहीं कर सकते. ये पता ही नहीं, ये सडनली होगा, कब मुझे नहीं पता. That's why learning about it is, the more and more you can know about it, becomes more and more important. So what is an earthquake? An earthquake, layman's language, is a sudden shake, or we will also say a jolt of the earth. Now this shake or jolt which happens of the earth, that can be at a minimum level or it can be at a maximum level. But whatever happens during this sudden shake or jolt, there will be energy release. And this energy is something which is going to create havoc for you. Okay? If the jolt is too, like what happened in Turkey a little bit, say 2 years ago, the last, it will be catastrophe. So let us understand what causes this earthquake. How do we measure earthquake? In our course, the maximum we have is what causes earthquake, how do you measure earthquake, what is the scale that you use for earthquake, then what is a seismic zone and all. So ye discussion karenge. Okay, ready? So what is earthquake? Seismograph is a plot. So what is an earthquake? An earthquake is a sudden shake or jolt of the earth. It's a natural phenomena. Generally is accompanied with calamity. There will be a lot of energy release, and due to this sudden jolt or shaking, this will be sufficient enough to bring down buildings and to cause havoc. Okay. So in order to understand the earthquake, we should first understand the structure of the earth. Earth ko dekhte hain. Okay. So if you see an earth in a circular form, say you're seeing a planar view of the earth, then the center of the earth is what we known as core. The core usually has molten iron, that is in majority, molten Fe. Fe stands for iron. So iron is majority, is molten, right? Due to this molten iron, there will be currents which are set up. These currents cause the magnetization of the earth also. After core comes another zone which is known as the mantle. ये हमारे लिए थोड़ा सा dangerous वाला zone है. This is the mantle. The mantle will comprise of, say, rock. Okay, and these rocks may be both solid as well as some rocks also in liquid form, which is the lava that comes out from volcanoes and all. So there you'll have molten as well as means liquid rock as well as solid rock. The mantle is core is always having molten iron. Okay? As a result, this is very hot, and then you have a semi-liquid zone. After that, you have what is known as the crust of the earth. The crust of the earth usually will have the rock, which are the lighter rocks, and these lighter rocks will then have soil and other things that will be embedded on them. इतना समझ में आया कि नहीं? Right? Now, जितना easy ये दिखता है, उतना easy वो है नहीं. Okay, so if you look at the crust, then the crust is not a continuous layer. The crust is actually formed out of plates. The crust has got plates, similarly like some plates like this. This is one plate, then there will be another one plate. Large plates are there in this crust. Now, these plates are also of two forms. Interest ke liye jano. If the plate is belonging to a portion where a continent, this is earth, na? So you'll have oceans and continent both, then it will be known as a continental plate. Continental plate. And if this plate is over an ocean, then it will be known as an oceanic plate. Oceanic plate. These oceanic plates are thin, whereas the continental plates are thick. So थोड़ा सा revise कर लेते हैं what all we studied so far. Earthquake, sudden shake or jolt of the earth, which causes calamity in the form of destruction. Non-predictable natural calamity. It's a natural phenomenon which is non-predictable. No such science is there which can tell you that this next month there is a chance of earthquake, right? Why earthquake happens? In order to understand that, we need to understand the structure of the earth. So if you look at the structure of the earth, the central part of the earth is known as the core, which contains iron in majority in its pure molten state, hot. Then comes the that we will see later. That is a measurement after the damage is done. We'll see all. Pay attention where we are now. Then comes the mantle, right? The mantle is a portion which is covered with rocks, which are solid rocks as well as liquid rocks also, right? So liquid rocks are actually in the form of lavas. So there's a lot of heat. After that comes the crust. The crust is the portion where you have the lighter rock, then they are surrounded by soil. And the crust is not a solid crust. The crust is actually formed out of plates. And you can think that these plates to be something like the tiles that are spread on your bathroom floor. You feel that your bathroom floor is one platform, but there are different tiles in it. And each individual tile can have a crack in it. And you understand? So similarly, the crust of the earth also has got a lot of layers in it. And these layers or plates are known as continental plate or oceanic plate. If you have a continental plate, then the continental plate is thick, the oceanic plate is thin. And they are not uniform. Like your tiles are uniform, they are spread, and plate to plate, they are arranged one after the other. Have you understood? Achha, ab aage kahani chalte hain. For the story to go further, now we have what? We have our plates. Tectonic plates, as we say. Plates. Now these plates are continuously under the impact of something called convectional current. So let us understand what is convectional current first of all. Convectional current. So to understand convectional current, come back to the basic of, say you have a saucepan in which you are trying to heat water. You are trying to heat water in this saucepan, right? So how does the water get heated? Obviously, you'll have a flame out here, right? The flame will first heat the vessel. The entire vessel gets heated by something which is known as conduction. Conduction means there has to be physical contact of the surface with the hot part. Now, how does the water get heated? You can try this. If you start heating water and you dip your finger, you will find that the water is not hot at the top portion at all. The water will always be heated from the bottom portion. Okay, this portion of water will get heated first. As this portion of water gets heated, it becomes light. It travels upwards and thereby pushing the top water below. Then the top water gets heated, it gets pushed. So what happens? A sort of current starts developing, a traveling current develops. This is called heating by convection. This is called convectional heat flow. Another nice example of it, if you are not understanding this one, let's look at your houses. Our houses are made in what way? Ventilators are always at the top and doors and windows are always at the bottom. The idea is hot air from the rooms are supposed to come out like this and cold air are supposed to get inside. Convectional current. जहां कोई चीज liquid form में रहेगा and there is heat being, they are being heated. So who is heating? The mantle is getting heated continuously from what? The core. And the mantle has got liquid inside it. Do you understand? So the entire mantle will not be heated in one go. So there will be a convectional current. All these sea breeze and land breeze. You know the story of sea breeze. Sea breeze and land breeze is a direct impact of convectional current. Land gets heated quickly and cooled quickly. During the day, Chennai, if you go to a beach, you will see anybody who is selling corn on the beach of Chennai. Daytime, if you go to the cellar, they will have a wind protector sheet on this side. At night, the sheet will come on the opposite side because daytime, the land gets heated. So hot air from the land rises, cold air rushes to take its place. So that is known as sea breeze. At night, what happens? The sea is still hot. So water heat, air goes up from the sea and then breeze from the land will go to take its place. That is known as the land breeze. That is also a convectional flow. Now out here, the plates that we had, where are our plates? Our plates are somewhat like this. Say this is one plate, this is another plate. These plates are continuously under the influence of something which is known as the convectional currents. Continuously. It is not that only on a what do you call the day when the earthquake happens, it happens on that day. No, it is continuously under convection. But they are like pieces of tiles, they are loose. So due to this, there is always a movement. There is always a movement. Movement. And when things move one with respect to the other, when one moves with respect to the other, we call this as a relative movement. There is a relative movement between these two plates. घिसा-घिसी कर रहा है एक दूसरे के साथ. So is the movement happening right now? Yes, the movement happens. This movement can be very slow or can be,
So fast?
vigorous. The movement can be slow or movement can be vigorous. If the movement is slow, that is what is happening today, right now also. You don't feel it. If the movement is vigorous, we will feel it. Now, what causes this slow and vigorous? That is the next thing. So what is the storyline? The storyline was first to understand the structure of the earth. So who is responsible? The core of the earth. What does the core of the earth contain? Hot iron in molten state. So once the hot iron in molten state is completely in heated form, it is also passing the heat to where? To the mantle zone, the mantle comprising of liquid rocks as well as solid rocks. As a result, some convectional currents are set up. These convectional currents cause the plates. What are plates? Plates are the plates which are on the crust of the earth. There can be a continental plate or there can be an oceanic plate also. So these plates also experience this convectional current and there will always be a movement with respect to one another. ये आगे जा रहा है तो ये पीछे जा रहा है. So relative movement is happening. This movement can be slow or this movement can be vigorous. If this movement is slow, you don't feel it as it's happening today. If it is vigorous, then you do feel it and comes calamity. We'll just divert a minute. Earthquake is not only due to these plates getting moved or something. The earthquake can also happen if somebody is doing some atomic tests right below the sea. Somebody says the tsunami was also a result of some atomic test, which people don't say, or some sort of underground explosions. If you do, that is also shaking of the earth. That is also known as earthquake. But that may be a man-made, created one. We are studying natural phenomena. That's why we don't study that. These are natural ones. Okay. So now let us see. Say suppose there are two plates. Okay. Let's have, this is plate one, and you can have one more plate out here. This is called the sideways movement. ये बुक में हो भी सकता है, नहीं भी हो सकता है, सुनते जाइए. This is a sideways movement. In sideways movement, two plates are actually brushing against each other, and they come to a bit of a still. If you observe this portion in a magnified form, let's say if we see it in a magnified image, we will see that one surface will have undulation, another surface will also have undulation, and a sort of interlock gets created. Interlock. So once the interlock is created, though there is a convectional current, further movement is restricted. Are you understanding? So maybe in childhood you have done something, you must have leaned across a wall and you go on stretching your legs in front, and your parent says, "Gir jaoge, mat karo." You are very happy you don't fall because your waist belt or whatever, your trousers must have created an interlock with the wall, but you are continuously trying to slide. Sometimes that interlock will be broken, and if that interlock breaks, then what will happen? You'll fall on your bums. The same thing happens here. The interlock is created, but they are under tremendous pressure from the convectional current. As a result, this interlock will break, and when this interlock breaks, it will create a sudden jolt of two plates having a huge vibration amongst each other, and that creates a lot of energy, and this energy is released in the form of shock waves, also known as seismic waves. These are some shock waves which will be created, and due to this shock waves, they will be so much strong that they might shake the foundations of any structures which we have created on earth. जैसे कोई बिल्डिंग हो गया, कोई पेड़ हो गया, इनके गिरने, फ्लाईओवर हो गया, इनके गिरने के बहुत सारे. इट्स सिंपल. आप इतना बड़ा केक बनाते हो, नीचे से शेक करते रहो तो केक गिर नहीं जाएगा, कैंडल गिर नहीं जाएगा. बिल्कुल वही हो रहा है. समझ में आया? फाउंडेशन जिस चीज के ऊपर है, तो योर फाउंडेशन इज ऑन सम प्लेट, and if that plate shakes, so that building shakes ultimately. But that shake is not something like it's very moderate. There will be a continuous shake which is happening due to sideways shaking. As a result of sideways shaking, the two plates will develop an interlock. जब तक interlock है, life मज्जा नहीं life, very happy. But one day the interlock will open, and when the interlock will open, there will be a brutal movement between these two plates, which will send a series of shock waves. Vibration हो जाएगा ना, shock wave आ जाएगा. That is one reason of earthquake. Have you understood? One reason of earthquake is due to the sideways interlock and movement of plates. Another type of movement that we see is two pieces of land masses where there are head-on movement. They are moving towards each other. This is the Himalayan zone of India. They move towards each other. ये move करते जा रहे, and when they move, there will be buckling from the top portion. Some portions will buckle, create shocks, and they will result in creation of more higher landforms, or higher landforms बनना शुरू करेगा. That's why we say, na, some of the mountain the ranges are happening. Why? The height of the Himalayas are increasing. They are increasing because there is a continuous face-to-face movement as a result. अब वो slow हो रहा है. यही अगर जोर से हो जाएगा ना, then also there will be some breakage will happen. Some valley might be created. Some river might start flowing. So if you see in where I have been born, brought up, so there's a place in Assam called Dibrugarh. In 1950, Assam had one of the worst earthquake. 1950. So where Brahmaputra now flows over in Dibrugarh, there was no Brahmaputra there. The river changed its course. There was the old court of Dibrugarh, the district court. The whole district court and the town went right below. Because there will be shaking, some sort of valley will be created. The river might change its course. So catastrophe is expected. So there are two types of movements of the crust of the earth. One is the sideways movement. One is the frontal movement, edge to edge, head to head movement. And head to head movement may also cause earthquakes to happen. Now, now we can't predict the earthquake. So what we can predict are something which are known as seismic zones. What are seismic zones? These are the zones which are more prone for earthquake. Sir, you can't predict earthquake, then how can you talk about this? We can talk about this on the basis of these are those children whose belt or their genes do not have good friction with the wall. Yet they are trying to do that exercise of leaning against the wall. Those are seismic children. Their chance of falling will be much more high. So these are those zones whose crusts have been analyzed and have been found that either the crust is very thin or the crusts, there is a partial motion which has been observed to be more than the motion between any other crust. In India, the entire northern belt, that is Jammu Kashmir to the Gangetic Plain and the entire northeast. So in India, Jammu Kashmir, the Gangetic Plain. Gangetic Plain means, you know, hey, this region, right from top of Himachal to Bihar, Sikkim to the northeast. These all are under seismic zones. These zones are more prone for earthquake. As a result, when you are doing some construction in this zone, you cannot follow the same construction technology that you follow. Like in Hyderabad and all, construction is very easy sometimes because you did not excavate deep. You have got rocks. So when you make buildings, the rocks will support you very good as foundations. Whereas if you don't, if you have a loose soil, then you have to excavate and go very much deeper. So much, that's one of the reasons that putting the metro rail on top here does not cost you much, because if you go underground it will cost you more. So you have to have, like, what are the technologies we use houses which are made up of light material, more of fiber will be used, more of mud will be used, so that catastrophe. Japan is very earthquake prone. The entire Japan, all the 7 islands, they are all under seismic zone. So wahan to hoga hi hoga. So if you see, you'll hear houses made up of paper, cardboards, other sort of fibrous material, which if falls also are not that much of a threat to human life. But imagine our houses. We are staying on concrete. If these 19-floor towers starts collapsing, can you understand what is the calamity that will happen? So nowadays, like we have in Roorkee, we have a place where you have the Central Building Research Institute. They recommend what type of houses, what type of material you should use considering the seismic zones. Okay, so once an earthquake happens, so what do we do? The meteorological department, the department which is actually monitoring weather and all, they have an instrument which is known as the seismograph. They have a device which is known as the seismograph. So a seismograph usually has a, ye aapko koi puchega nahi, there is a small drum, and the drum will have your graph sheet like of paper, and this drum is continuously rotating. On top of this drum you will have a big weight, and on this weight will be suspended a plotter. Plotter means a pen like thing, और ये घूमते रहता है. So the plotter experiences, due to this weight, it will steady still, but if the earth shakes, the plotter also shakes. So and this is rotating at a slow speed. It is continuously printing seismographs. Are you understanding? There is a plotter and there is a roller. Kitchen tissue roll dekha hai? So take the kitchen tissue roll, and on that you put your plotter and ask somebody to keep on pulling the roll. So it is continuously plotting. So you get some spikes and other thing. If the earth is shaking vigorously, the seismograph will also shake vigorously, giving you an early indication to some extent that you can expect something to happen. So the earth's shaking is continuously monitored by this device called seismograph. So what you might be asked is, what is the weather department uses what type of instrument? A that is known as a seismograph. A seismograph is used to measure the vibration of the earth. And when earthquake happens, the earthquake is measured in a scale, and that scale is known as a Richter scale. इसके बारे में थोड़ा जान लो, ये आपके कोर्स में नहीं है पर ये इंटरेस्टिंग है. व्हाट इज रिक्टर स्केल? इन हायर मैथमेटिक्स यू स्टडी समथिंग कॉल्ड लॉगरिथम. देखते हैं रिक्टर स्केल होता क्या है. ये आपको बुक नहीं बोलेगा, बट यू शुड नो. Sometimes you'll hear they had a earthquake of Richter scale 6.1. Anything above 6 is dangerous. Say somebody had a earthquake of 4.2 or 4.3. You feel that बहुत आसपास है, ऐसा नहीं है. Let's see how the Richter scale is designed. You have learned how to make graph. You had used kinks. Suppose I ask you to make a graph where I should be able to measure the diameter of an ant's eye, and also I should be able to measure the turnover of a company like Microsoft. एक ही स्केल में समझ में आ रहा है? Ant's eye as well as turnover of Microsoft. Both these are two different things. So let's go by length, or say length means this won't be a right example. See, I ask you, and you also tell me the Delhi's airport's runway. I want to measure both on one scale. Ant's eye as well as the runway of Delhi Airport, one of the biggest runway of India. So we want to measure both. This is in kilometers, and this will be in millimeters, micrometers. दोनों एक ही स्केल में मेजर करना है, एक ही ग्राफ में मेजर करना है. So if you do on a graph paper, the graph paper will become very long. So what we apply here is something known as logarithmic scales. So how does logarithmic scale work? So say suppose you want to represent something which is 1. Can I represent 1 as 10 to the power 0? Yes, allowed. My next scale is 10 to the power 1. So I'm measuring what? 10. My next scale will be 10 to the power 2. So I'm measuring how much? 100. My next is 10 to the power 3. So I'm measuring 1000. My next is 10 to the power 4. So I'm measuring 10,000. So I change this entire scale and I write it like this: 0, 1, 2, 3, 4, 5, 6, 7. Richter scale is like this. So if somebody says my earthquake was in Richter scale 6 and somebody says my earthquake was in Richter scale 4, आप बोलोगे 4 और 6 आसपास ही था ना. He is 100 times more than you. 10 to the power 4 and 10 to the power 6. This jolt is 100 times more than the jolt you faced here. This is known as logarithmic scale. You'll learn about this scale later when you do PH in chemistry and all. So these are called logarithmic scales, where you can measure small value and large value simultaneously. At your course level, people will ask you, earthquake intensity is measured in which scale? Richter scale. And how is the earthquake's damage measured? Well, seismograph is also used to measure the continuous vibration of the earth. तो अभी आपने अब तक क्या क्या सीखा आज? You learned about a basic definition of earthquake. Check whether you have understood these or not. Earthquake, you learned about the structure of the earth structure. This was the next thing that you learned. While you learned about the earth structure, you got to know about two new things. One is about the plates, and the plates were also of two types. You learned about continental plates, and you also learned about oceanic plates. Okay, then you learned about convection currents. Convection currents, right? Apart from plates, we also learned something called core, mantle, and crust. While the plates are directly responsible from the crust, the mantle is the one which is heating the crust and is actually causing the plates to move, and the core is having molten iron. Clear? And then between these, due to this convectional current, then you have two types. You have movements, plate movements. These movements were of two types: sideways and head-on. Both are going to cause calamity for you. And these sideways ones will actually create what? Interlock. And then there will be sudden jolt. And then you'll have seismic waves or shock waves which are being created. Shock waves or seismic waves. Then you also learned about something called the seismograph, an instrument which is used to measure the vibrations or monitor the vibrations of the earth. And we also measured about something which is learned about something which is known as the Richter scale. Richter scale is the scale in which we record the intensity of the earthquake. How harsh the earthquake. More is the number, more it is intense. Anything above 6 is tremendous damage. Anything above 6, 6.5 means you can expect huge damage has happened. Right? So another question comes, is there a vibration that is happening in the earth right now? Yes, everywhere it is happening. Acha. We also learned about, apart from this, this, then we understood something about seismic zones. Seismic zones are the ones which are more prone from earthquake because the vibration is more. ठीक है, अब इतना कुछ जान लिया तो थोड़ा सेफ्टी जानना चाहिए. What happens if a earthquake, if there is earthquake? Earthquakes, have you experienced earthquake? Anyone? Okay, when the earthquake happens, it will happen for a very short period of time. So basically, जब तक आपका दिमाग set होगा, तब तक earthquake हो चुका होगा. So when people say in earthquake do that, I just don't understand how will somebody remember that you have to do that. Okay, still we should say, if any earthquake happens, first is, if you are inside a building, take shelter. Take shelter where under kitchen slabs, desk, heavy things which can't break, but your kitchen slabs do not have any place for you to go because they are already loaded with lofts and everything. And if you are in outside, it's just like the opposite of electricity. Get as much as possible to free space. Do not be within any space like where something can fall on you. Majority of the death happens because people get crumbled under the debris and the death is very painful. Let's accept it. Earthquake, yeah, we have experienced. Delhi and all earthquake, like there was once in 2005-6, we were in Delhi. In front of me, like television's almost the whole TV. Then if you have chimes and all in house, suddenly they will make noise. Wall hangings will move, fan move kar jata hai pura. The recent one which happened in Turkey, if you go see the videos, then you'll see all those things which are kept in departmental stores, like kitchen units. You have those rice spoons and other things displayed. They just calm, and you will have no time to come out. For us, earthquakes is more dangerous because now we are no more living in independent houses. We are all in what, high-rise apartments. So if earthquake happens today in Hyderabad where we are, kiss yourself goodbye. There is no way you can. Miracles can only save you. Otherwise, at that time, let me open my science book and the notes also. Sir had said, get underneath a shelter. वो सब time ही नहीं मिलेगा तुमको. Because one shake, the whole thing will start falling down. It's like a deck of cards. कोई chance ही नहीं है. But if you see by grandma stories and other things, animals can sense earthquake little bit before you. Like typically snakes, cats, dogs. Dogs will become silent. They can sense. No, no, because snakes have that. Snakes don't have ears. Snakes can only sense the vibration, and snake is very sharp. In when you walk, a snake goes just rattles away. Why? Because the snake can't hear. All those stories where people used to play those snake charmers, that's because the snake feels the snake is getting attacked, so it is to make movement. The snake senses the vibrations of its skin. Cats are very good indicators of what you call earthquake. Dog will absolutely become silent. So you can get to know. Cat also becomes silent. Snakes come out of their hideouts. They can sense it before. It's just like you putting your ears on the track of the railway line and that you get to know that the train is approaching. So thing is, take shelter. But like storms and other things are prolonged, you can know what to do. Here you won't even get to realize what to do. Take shelter, number one. Number two, if you're outside, get into open spaces. The more you get into open spaces, the more you are actually making yourself free from getting hit by something. See, your death won't happen due to you getting washed away. Yes, if you're in the hilly zones, then due to earthquake, river might change its course. At that time, there is a fear that you will get washed away. That happens a lot in northern India, Kailash and all this, Kedarnath and all. Then another thing that can happen is landslides coming down. So your death is more by the chance of you getting buried under some debris. And with these high-rise buildings, 1 or 2 towers falling down, then after 7 days we will get out somebody almost apple pie jaisa niklega, tart, apple tarts. We have Jaideep tart today. But some people are there who have remained buried in debris for 7 days and yet survived. God is really kind on them. ठीक है? इस chapter में इसके अलावा और कुछ नहीं है. So if you want to ask something, we can ask, or if you have some doubt in maths or something, we can do our maths doubt. So lightning, we are all done with our science syllabus. I'm just stopping the recording because, okay. So